Hello everyone, this is Denver Droha from STEM 11 Mundo, back at it again with another basic calculus video. And for today's video, we are going to tackle another rule regarding how we solve or how we find the derivative of a function. So without further ado, let's get right into it. So the rule that we're going to tackle today is all about the chain rule. Sorry, where it states that the derivative of f of g of x is equal to the f prime of g of x multiplied to g of x. What it's essentially saying is that first you're going to find the derivative of the function, the f function, using g of x as normally it's x and multiplying it to g of x, the one inside. So let's try and give an example. So for our example, let's use a trigonometric function using this. So we're finding the derivative of cosine 3x squared. So as the rule states, we're going to first differentiate what's our outside term, or the one that envelops the smaller term, which is the cosine function. So our f of x is going to be cosine times 3x squared. Cosine of 3x squared pala. So now we're going to find the derivative of this one, which is going to be f prime of x is equal to, what's the derivative of cosine? That is negative sin 3x squared. So that is the derivative of our first term. Now let's do it for the second one, which is g of x. G of x is the one that is being enveloped by the larger. So that is going to be 3x squared. So g of x is equal to 3x squared. Now we're going to use the constant multiple rule. So g prime of x is equal to 3 times, put the exponent in the front, 2x raised to 2 minus 1. So perform the indicated operations. 3 times 2, that is 6. X 2 minus 1, that is 1, which is not necessary to write, so that is 6x. Now let's perform the chain rule, where it states that we're going to multiply the derivative of the larger, of the one that envelops the smaller one, and we're going to multiply that to the function that is inside that smaller one, so that bigger one, I mean. So the derivative of cosine 3x squared is going to be f prime of gx, that is this one, negative sine is 3x squared multiplied by 6x. So that is going to be the derivative for cosine 3x squared is negative 6x sine 3x squared. So that is our final answer. So let's try and solve another example of the chain rule. So for the other example, we're going to find the derivative, sorry, the derivative of, x squared minus 4x raised to 3. So we're first going to find the one that envelops the smaller function. So obviously our smaller function is going to be this, x squared minus 4x. So where's the bigger one? In the earlier example, we can see that there is a cosine beside the smaller one. So, but in this equation, there's none. But we can see that there is an exponent. So this implies that we're going to be using the composite, the power rule for us to find the derivative of the larger equation. So the derivative, or f of x, is equal to x squared minus 4x raised to 3. Now we're going to be using the power rule. Place it in the front. F prime of x is equal to 3 times, just copy, x squared minus 4x raised to 3 minus 1. So that will give us f prime of x is equal to 3 times x squared minus 4x, 3 minus 1, that is 2. That is our derivative for the first term. Now we're going to find the derivative of our second term, where g of x is going to be equal to the one inside this one. So this is simply just x squared minus 4x. Now we're going to use the difference rule, sum and difference rule, where it states that we're going to need to find the derivative of each of these terms respectively. So using the power rule, place it in the front, 2x raised to 2 minus 1 minus 4x, using the constant multiple rule. Separate the one inside, separate the constant, 4, multiply it to the variable where there is an invisible 1 here. There will be 1, x raised to 1 minus 1. So again, perform the indicated operations. 2x raised to 2 minus 1, that is simply 2x. And then 4 times 1, that is 4. X raised to 1 minus 1, that is 0. And subtract. G prime of x is going to be equal to 4x raised to 0, that is just going to be 1, so 2x minus 4. So that is the derivative for our second term. So now let's perform the let's substitute all of this into the formula, which is the derivative of x squared minus 4x raised to 3 is going to be equal to the derivative of the larger, or the one that envelops the smaller function, and which is this one. Let's write it. 3 times x squared minus 4x squared multiplied to the derivative of the one that is being enveloped by the larger function. So this one, 2x minus 4. So by the way, I made a wrong statement earlier where I said that in chain rule you're just going to multiply the derivative of the larger equation to the original equation inside, where that statement is wrong. So I apologize. This is actually f g prime of x, not just g of x. So sorry for the misinterpretation. In the process of solving of the first example, where we used this one, the process was right. So there's no problem in the answer in the first equation. This is right. But yeah, so let's continue. Let's perform the operations where we're first going to square this binomial. So by using the technique, we're going to copy the 3. We're going to square the first term, x times 2, x squared times x squared, that is x raised to 4, and then twice the product of the two terms, which is negative 4x times x squared, that is negative 4x cubed times 2, that is negative 8x cubed, and then square the last term. It's going to be positive 16x squared multiplied to 2x minus 4. So again, distribute this. That is going to be 3x raised to 4 minus 32x raised to 3 plus 16, 32, 48, 48x raised to 2 multiplied to 2x minus 4. So let's use another paper for the continuation. Here. So let's rewrite. Derivative of x squared minus 4x raised to 3 is equal to 2x minus 4 times 3x raised to 4 minus 32x raised to 3 plus 48x squared. Now let's distribute 2x times 3x raised to 4. That is 6x raised to 5. 2x times negative 32x cubed, that is negative 64x raised to the 4th power plus 2x times negative plus 48, 2x times 48x squared, that is 48 times 2, that is 96, 96 x raised to 3. And then now we're going to multiply the second term to all of these again. Negative 4 times 3x raised to 4, that is negative 12 x raised to 4. Negative 4 times negative 32x raised to 3, that is 32 then plus 32, 64, 128 plus 128 raised x raised to 3 minus negative 4 times 48x squared, that is 48 times 2, 96 times 2, 96 times 2, that is 12, 192 x squared. Hold on, let me check that. I'm just doing mental math. Sorry. 48 times 4. Oh, it's correct. So now let's combine like terms. So 3 to 5, none. So let's copy negative 64, and this have the same exponent, so negative 64x raised to 4 minus 12x raised to 4. So the um, the rule keep change, so keep this one, change these two, so that is plus, that's minus. That will leave us with 76. Yeah, 76x raised to 4, and then these two has the same exponent, 2, which is 3, and a 6 plus 128, that is 224. Hold on, let me check that again. 96 plus 128. Okay, that's correct also. Times x raised to 3. Then copy the last term, which is negative 192 x squared. And so upon checking, I have made miscalculation. 32. This was supposed to be 24. Sorry. So let's check. 16, 32. Yeah, this is correct. So let's change this one. So again, 2x times 24 x squared, that is not this one, that is going to be 48, and then negative 4 times 24, that is 48 minus 6 is not 128. So again, let's perform the indicated operations. 96 x cubed minus wrong. So let's erase this. Sorry for the dirty I mean, never mind. So copy this one, 6x raised to 5. Now these two has the same exponents, so negative 48x raised to 4 minus 12x raised to 4. That will give us 60, negative 60x raised to 4. 96 plus 96, that is going to give us 192. 192 x cubed minus 192 x cubed, I mean not 109 minus 192 x squared. So yeah, that is our final answer. So that'll be it for today's basic calculus video. So I hope you have learned something new. I hope I was clear with my instructions and the way I teach. So yeah, thank you for listening, thank you for tuning in, and till the next video. So goodbye, bye bye, peace.